Okay, today we will continue on matrix acidization, matrix stimulation. Yesterday we talked about the matrix acidization placement. So we have to try to make sure that we place or inject the acid or required amount of the acid into the proper zones which have the most damage. Therefore, we use some diversion techniques, which include bullheading or circulating with coil tubing or the work string. Bullheading is, as we learned yesterday, can be itself potential formation damage source, as we may inject into the into the formation the rust or any other scaling, pipe dopes, any other solids and materials that are on the tubing surfaces into the reservoir, into the formation, and that will lead to the formation damage, formation impairment. Therefore, working with the bullheading, we have to make sure that we have cleaned the tubing existing in the well tubing with the circulation of acid within the wellbore down to perforations and back to the surface. Without any injection, any pressure, just without letting the acid going into the formation and possibly protecting perforations as well. So nothing goes into the formation during the bullheading. The same clean tubing we have to make sure that we cleaned those coil tubing and the pipes that we will use for as a work string for this acidization job, to make sure that we clean them from rust, scaling, pipe, any other mud, if they are drilling pipes, then they must be cleaned, dried mud or any the additives that we use in mud fluids. We've learned some diversion techniques when we use a coil tubing with the spray head diverting fluid into required angles and using the packers to make sure that we inject the acid, the required or designed zone, and then change the packer location and inject to the next zone. Another, here is a different techniques. Bullhead treatment for bullheading, we use different techniques like ball sealers, chemicals, and straddle packers, and a nitrogen foaming, which will block the by the surface tension increasing surface tension and block the increase the viscosity. So the acid will not go to the high permeability zones, but will go to the zones that are highly damaged with the formation damage. Okay, here how this ball sealer works. First we clean this zone and then inject ball sealers to block this zone to allow the acid on the next stage to enter the next zone and clean the next zone, and then back produce with the ball sealers back to the surface. And this is the typical acid job in sandstone when we do pre-flush with the HCl of 15%. Then we inject a regular mud acid with 13% hydrochloric and 3% hydrofluoric acids. And then we overflush or post-flush with the 4% HCl to clean the
We can't hear you.
değil tabii bir saatten sonra. Sorry. Okay, just let's go through again. So we talked about the placement of the acid, bullheading, and coil tubing or workstring. Bullheading may result in formation damage due to rust, scale, or pipe drop in the tubing. These will all will be injected into the formation. So we have to clean the tubing or coil tubing or the workstring pipes from any rust, any dirty material, to make sure that we don't inject into the formation any additional solids or additional don't lead to the additional formation damage. These are the diversion techniques with the coil tubing, when we use a nozzle that will be injecting into only this zone, or the better is about it's a little bit expensive using these packers, dual packers, and inject into one zone, and then change these packers, injecting into another zone. For bullheading, we use ball sealers or chemical sealers, again straddle packer, and foaming materials that will increase the viscosity in these areas, and the acid will go into the mostly damaged zones. And this is how the ball sealers. First, we clean the the zone that is less damaged, and then we inject the ball sealer. Sorry. We block the sealers that we block with these ball sealers the zones that are already cleaned and high permeability to inject, to allow the fluid, injection fluid, to enter the zones that are still damaged. And once these are also damaged, cleaned, we flow back the well, and these ball sealers are flown back to the surface again. So this is a acid job, typical acid job design for the sandstones, when we pre-flush with the HCl 15% to clean all the carbonate, calcium carbonates before injecting the regular mud acid, because mud acid reaction of mud acid with the calcium carbonate will create calcium precipitations and calcium chloride precipitations, and these will be additional formation damage, and therefore, and then so the main fluid, the regular mud acid, will dissolve the clays or the mud fluid solvents and clean the damage, remove the damage, and then we post-flush or over-flush with the HCl 4% concentration to clean the precipitations or secondary acid, secondary reaction materials away from the wellbore, so we can create a very clean zone around the wellbore. And also we may have added some additives to suspend those materials, those solids or fines in the fluid. So when we flow back this fluid, it will not precipitate, it will be flown back to the surface, cleaning the wellbore area. And as a next stage, we before we move to the next stage, we inject the diverter slug, and this diverter will plug the zones that we have already cleaned, and then again pre-flush for this new zone, and then main fluid for this new zone, and overflush again, and a tubing displacement. So there is we clean the tubing as well from these all this material, and then reinstate the production. So that's kind of a two-stage acid job, and the number of stages depends on the number of zonation in the reservoir and the severity of damage for each zone. In the carbonate formation, we've learned that the carbonate formation are different nature, and therefore acidizing in carbonate is mainly to create, to bypass the damage and create wormholes around the wellbore, increasing the wellbore radius, effective wellbore radius, and this happens on the vertical surface and the lateral surface. So the whole perforated zone or open hole zone is covered by those wormholes. So the damaged zone is bypassed, and the conductivity with the reservoir is improved. This is kind of a experimental calculations of the relation between the total injection volume and the wormhole penetration length. So the increasing the injection volume will increase the penetration length in parabolic function as per parabolic function, and that may be up to the 20 feet beyond the wellbore, which is quite a large. And as you can see here, we increase the influx area or influx zone substantially for carbonates with the matrix acidization. And this is a kind of a experimental, again, the laboratory tests results for the carbonate acidization and showing the relationship between the injection rate and volumes. So the injection rate and volumes are affecting the creation of dense channel system or wormhole systems around the wellbore. And it all depends, of course, carbonate formation reactivity, so the mineral composition of the carbonates. The rate of the injection, the acid injection, and presence of the hypermobility strikes, fractures, books, meaning that, of course, firstly it will go through the hypermobility strikes, fractures, and books, and will create further wormholes and channels through these high permeability zones. Another type of carbonate formation acidizing is acid wash, and here its objective is to remove near wellbore damage, perforations, the cement, rather than wormhole formation. And here we inject it at very low rate. You can see it's less than cubic millimeter per minute per meter of injected zone, and using the highest possible HCl concentration and leaving this acid in the wellbore for long time. In this case, coil tubing to replace the volume of acid with the coil tubing equal to the casing volume and perforated interval, and then we leave it to let the acid do the job around the near wellbore damage and perforations and the completion around the cement, and then we flow back this, and then again produce the well back, start producing the well. So this is what we covered yesterday, and again all this is about the candidate selection, treatment design, and operations we talked about, and now evaluation is another important part of it when we evaluate treatment success, and if there is a need, modify stimulation guidelines. Evaluation of the acid job is based on the data that we get from the acid job. That's the pressure data, like wellhead pressure, annulus pressure, pumping rate, the balls, the downhole pressure, etc. And here we can see that When we start injection, pressure rises quickly because we have a resistance to the flow, and as the acid starts reacting with the carbonates, we can see the drop in the pressure because acid starts reacting with the carbonate, opening new wormholes, and fluid goes into the reservoir easily. And as we've done the first stage, we inject the ball sealers to block the firstly cleaned zones, and then again, as we start the balls into the reservoir, into the wellbore, we can see every time as we inject the ball sealers increase in the pressure as because now the ball sealers are blocking the easy way for the fluid flow, and the fluid again get resistance from damage. And as soon as the reaction with the carbonates, acid starts reacting with the carbonates, the pressure goes down because now again some portion of our zones are open or cleaned or bypassed the damage, and fluid gets easy way into the reservoir. So all this is to ensure that all chemicals and diverting agent are pumped as per design. So we regulate the rate of the injection, the volumes of the injection. We have to compare pre and post simulation test to evaluate skin, how the skin changed, did we get the results that we expected. We need to collect the return spent acid, evaluate for sludge and iron content from the flown back fluids during the production, and to test what was the result and how it reacted with the fluid, the reservoir fluids. Of course, keep records of the volumes, pressure, samples to make sure that everything goes by the plan, and monitor well for any decline, and use of we may use the radioactive tracers to see how long, how deep this acid may go into the reservoir, how would it be observed in other wells, or how long it will take the effect of this acid job. Okay, again, you have seen this here. We have a the post pre-job and post-job PLTs, and here you can see that only the upper part got effect from this acid job. The rest are producing at the almost the same rate, so low effect of the for the acid job. This is a skin evolution from the beginning of the acid job to the end of the acid job, with the injection of fluids. Initially, we inject the water, and then aromatic solvents, and then HCl for pre-flush, and then regular mud acid. So the substantial decline in the skin effect is observed once we start injecting the HCl and then the mud acid. Sorry, mud acid. So the skin is reduced from 38 to around two value. So that's very substantial reduction of the skin, and the result of this will be high production incremental. This is a kind of example of acidization campaign when the stimulation curve of statistical curve of the well productivity shows that the average well productivity is around 0 to 35, and many wells are working have a very low productivity relatively, around 0.2 or 0.3, and after the acid job, the distribution of the wells changed in terms of productivity, and we can see that average productivity now almost twice, calculated at 0.65, and the also the majority of wells now have a productivity around 0.5 to 0.8. This is huge change in the productivity of the wells, and the campaign, as it says here, campaign delivered increased production capacity at 10% of cost of infill drilling, although the 15% of this acid job was a failed. Okay, and despite that, they got very good results, almost doubling the productivity index, and the majority of the wells had increased the productivity as well. So this peak is moved to the left, to the higher production direction. This is the results of the long-term stimulation campaign in an oil field. So high early gains expected since best candidates treated first. Gain halved over 5-year period, but later treatments more economic, smaller volume, cheaper additives, etc. So this is a increased production, and this is through the time it was decreased, but also the cost of the job was decreased. So essentially the final incremental rate is also, although it's halved, but economics also halved. So the total economic value of this is still profitable. Here, alternative acid formulations, application of alternative acid formulations with the proprietary acids. Proprietary acids are the compositions or formulations that a company, laboratory or company personnel work on this and create their own composition, maybe based on the major compositions, or they do their own composition, and it's called proprietary. So it's their formulations, their composition is not known, but here you can see that the gas production after the application of full-strength mud acid treatment gas production increased, but then rapidly decreased. And when they applied proprietary acid treatment, or their own acid formulation, the increase in production was a more sustainable, lasted much longer. And these are the trunk line reduction restrictions. So this is not related to the field production. This is related to the infrastructure restrictions. But the main point is that using the proprietary acid system helped much longer in the time perspective. Here is another example of the proprietary acid. So here also this plot is showing the rate of the gas against the pressure. So the higher pressure to get this rate, the more energy is used, or more depletion of the reservoir. So this is the full strength mud acid effect. So at some point after one, the effect of mud acid is decreased, or I mean, it worked poorly, because now again, to produce, for example, this amount of gas, we need much higher rate. Sorry, the pressure the pressure change. But using the proprietary acid, it worked for the squares measured during the more than 40. So this is the 4 years effect of the proprietary acid. That's kind of a comparing the conventional acids to the proprietary acids that are developed specifically for this field, for these rock characterizations, fluid characterizations. For example, in this case, full strength mud acid was too aggressive, and it provided many fines. So those fines precipitated and created even more formation damage to block the pores and create even more formation damage. But proprietary acid was designed exactly for this case, for this field, for this rock properties, mineral content, chemical composition of fluids, and the rock, and therefore it worked for a longer time. The proprietary acid is not something that somebody easily obtain. It requires a long time studies and a long time laboratory experiments to achieve the desired results, or to achieve better results than the conventional acid formulations. Another way of matrix stimulation evaluation are using the formulas. For example, here we have a flow efficiency formula, flow efficiency calculations for simulated productivity against the damaged productivity. So we have a damaged productivity and the productivity after the stimulation. So And these calculations will help to evaluate how much this efficiency has changed in terms of for example, we can see here the stimulated permeability against the damaged permeability change and how that affected the productivity effect, how much the productivity was increased over the damaged one. These are given in the petroleum production systems by Michael Economides, and I would recommend to read this matrix acidization, matrix stimulation chapter in this book to get more insight into these formulas and into these evaluation methods. For example, if we evaluate the stimulation of the undamaged well, for example, we want to increase production. There is no damage, but we want to increase production, especially for carbonates, and we inject acid, and that is a with different. That's the results with the different penetration rates when the penetration is 20 foot, 10 foot, and 1 foot of the acid, and those are the results that we can see from the non-damaged well. And the effect of precipitated zone productivity, we can see here how it's calculated based on the inner radius of the collar, damaged collar, and outer radius of the damaged collar. So that's the calculations helping us to evaluate the effect of stimulation, the effect of created damaged collar, and how that will be seen as a part of the productivity. Okay, so that's it for the matrix acidization. Do you have any questions for this chapter? Hello? Hello?
Teacher, yes, I have one question.
Yes,
Should we learn these chemicals by heart? There is a number of the chemicals, how what they use in the simulation.
yes, of course, you have to know which composition works, how it works, what are the chemical results of chemical reactions, what can be kind of precipitations, what kind of precipitations you can expect from this or another chemical, depending on the. So you have to understand what you are applying. So if you tomorrow you go to your or boss comes to you and says, well, I want you to design a acid job, you have to understand what kind of acids will work and how they will work.
Okay, understood. Thanks.
You're welcome. So if there's no questions, we would move to the next chapter. Of sand management. Okay. Here are the learning objectives, what you have to understand, what you have to learn and be ready to explain or to discuss and describe. So the sand production is one of the major problems in the petroleum industry because many hydrocarbon drilled wells are in sandstone reservoirs. As it says in this slide, although approximately 60% of the world's oil and gas production comes from the carbonates, 90% of hydrocarbon wells are in sandstone reservoirs. And this is because many small fields are related to the sandstone reservoirs, and number of wells are in the sandstone reservoirs are much higher because in carbonates there are a lot of application of horizontal wells and they have multilateral wells, and therefore the number of wells there are the wells are drilled into the sandstone reservoirs are much more, and the sandstones usually are quite weak to produce sand. The sandstone, as it says for the name, is the mainly is a sand that is compressed together or cemented together with cement material, and sometimes it is very strong sandstone, very strong cementation. Sometimes it's very weak. There are reservoirs that has just a very unconsolidated sand rock, which would crash just under very small stress, and that is the results. But even strong sandstones might be a source for the sand production because the pressure reduction, pressure depletion in the reservoir, fluid movement in the reservoir, depending on the viscosity, mobility of the fluid, chemical composition, may trigger the cementation and the pore pressure weakness, and this may trigger the fines migration of these sand bodies, and then once it's started, it will go further and increase as we increase the rates, as we increase the pressure depletion in the reservoir. Okay, and even some carbonate reservoirs may also produce solids because carbonate reservoirs, as we learned, are very fine material, and once we start, for example, acidization, we may have some fines migration here as well because of a cementation broken, and it may also produce some solids in the form of fines into the wellbore. And any production of these solids into the wellbore will lead to the sand bridges in the tubing, damage to the well equipment, because at high rates, at high flow rates or moderate flow rates, those particles, solid particles, become a very erosive, and it might lead to the erosion and collapse of the tubing, casing, surface equipment, and also there is a problem of if we start producing those sand to the surface, then we will have a problem of disposal of this sand. So we have to do something with this sand. So to decide on what do we need the sand control equipment to be installed, it is a question of development phase. It is a question of the field development planning stage. After we do appraisal, we appraise our reservoir, we appraise the rock materials, we assess are we going to have sand control, sand production or not? Because omission it or not installing will bring some production losses through the causes or reasons that I just named, like sand plugging in the tubing or erosion of the well equipment and surface equipment, the disposal of this produced sand, etc. Or if we include it unnecessarily, for example, somebody says, well, let's have sand control because it's looks nice, or we just will be on safe side. This may cause very high cost effect in terms of extra capex, depending on the method you choose for the sand control. It might be very expensive or lower expense, but it's still extra capex because we invested in the beginning of the project. So its negative effect on MPV will be also very high. It might present future workover flexibility limitations. Like if we install sand production equipment, then the going through this sand control equipment is not easy. With or in some cases, in some options, it is not possible. So we limit the potential workover possibilities in this well, or it might be difficult or impossible to monitor the well production with PLTs or other equipment to run into the hole, to go through the producing intervals to see which interval is producing more or less. So that are the and also any sand control equipment is an obstruction on the production flow, and therefore it will potentially reduce the well reserves. So the reserves are related or within this well drainage area. It may cause production rate reduction and hence increased lifting costs. And this is if we install those unnecessarily or install those without having very deep and thorough investigation. Okay. So it's time to finish. So we will continue tomorrow on how the sand production occurs, why we get this situation, and how we can work with this sand production. Okay, questions?
No questions so far.
Okay, see you tomorrow then.
See you.
So.
See you. So.
Sağ olun.